Hi everybody, I hope everybody's doing okay. I had a few people reach out to me because they missed 9.2 because of region travel, which totally okay. And one of the hardest parts about the stuff we do in Chapter 9 is finding the Apothem. So what we're going to look at is we're going to find the area of a polygon. I should have included the word regular right there. And remember that regular means all congruent sides, all congruent angles. So we kind of present this a little differently than the book. We say the area of a polygon is 1/2 ASN. A stands for apothem. S is side length. And N is number of sides. So what I'm going to look at today is I'm going to do a pentagon. So we're going to look at a regular pentagon with side lengths of 8 inches. So first thing I like to do is draw a picture. Here we go. So if we have a regular pentagon, looks something like this. All the side lengths are 8 inches, and because it's regular, those are all the same. So for our formula, 1/2 assassin, we do not know the apothem, we do know the side length, and we do know the number of sides, because it's pentagon. So the tricky part with these guys is finding that apothem. Now the apothem is from the center of the shape, it is the distance from the center perpendicular to the side. That is your apothem. Now the cool thing is because we've learned about them, is we can actually break this shape up into triangles. And if you look, if it's a 5-sided shape, there's going to be 5 main triangles. So to figure out what one of these central angles is, you're going to go 360 divided by 5. So if you go 360 divided by 5, you get 72. So that means this angle is 72, this one's 72, this one, and this one. Now if we look at this triangle a little bit bigger, this entire angle is 72. From here all the way to here. But in order to find the apothem, I'm going to drop in this height. And what does that do to this angle right here? It cuts it in half. So if we look here, this is my apothem. So what I did is I'm going to draw this bigger over here. And because it's also regular, that means this is the same as this, which means it's an isosceles. So that means the height of this triangle cuts the base in half. So if this whole thing was 8, this piece right here is 4. And if this whole angle was 72, this also got cut in half and it is now 36. So what we're going to do here is we are going to use our trigonometric identities and functions in our trig table to figure out what this A is. Now remember, from the 36, the 4 is the side that is opposite it. So that's my opposite. The little a next to it, that's my adjacent. And so I have to remember, and this is probably a little rusty, what trig function uses opposite over adjacent. So we're going to look at SOHCAHTOA. And we'll notice that opposite over adjacent, we're going to use tangent. So we have the tangent of 36 is equal to the side opposite over the side adjacent. If you do not have a trig table, you could probably just go online and type that baby in there. I'm using a calculator. And this is what I get. I get 0.727 equals 4 over A. And I don't want the A on the bottom, so I'm going to multiply both sides by A. And last step right here, divide by this. The thing I like about making these videos is that you can pause and repeat if you need. It's kind of nice. And there's your apothem. So now that I know my apothem, I can go back up here, 5.502, and I can figure out what the area is. So the area is 1/2 my apothem times my side length times my number of sides. And I got 110.04. Oh, what was the units? Inches. Square inches. That is how you find the area of a regular polygon. The tricky guy is the apothem. Thank you for joining. Have a good one.